Thank you for joining us on Let's Talk Shop. I'm Maggie Mahler, Product Marketing Specialist at Vermeer. With me in the studio, I have Andy Bremner, Sales Manager for Vermeer's Pipeline segment, along with Gary Castleberry and Mark Miller from Geoengineers. Today, we'll be talking about alternative applications for your maxi rig and new opportunities for large and maxi horizontal directional drills, or HDDs. Before we get into the conversation, let's hear from the team on our panel. Andy, can you tell us how you serve Vermeer's pipeline customers and partners?
Sure. So as the sales manager for the pipeline division, I'm responsible for the commercialization strategy for our HDDs 100,000 pounds and larger, and also for our drilling fluid reclaimers and our high pressure mud pumps. In addition to that, coordinating with our dealers to make sure that our personnel and other resources here in Pella are in lockstep with our dealers, just to really provide that support. And also with this role, we're working a lot with our product management team and engineering teams to take back the voice of the customer, you know, as things change, especially like as we kind of work through this decarbonization initiative and just, you know, reinforcing our current infrastructure, making sure that we're taking the voice of the customer back to our product development teams and engineering teams to make sure that we're providing an innovative product that's delivering on our brand promise. And so a big part of that too is really understanding at a high level the economic indicators that are driving the business, right? So that's kind of a big part of the conversation today as we talk about, you know, this movement towards decarbonization and what that brings as far as carbon capture, hydrogen, renewable natural gas, infrastructure that reduces flaring, whatever it may be. And also just some of the other infrastructure around key resources. So that's water, municipal type of infrastructure that's going to be bringing some new opportunities for our maxi rig customers.
Great, thank you. I'm excited to have Gary and Mark from Geoengineers on the Vermeer Mile. Can you guys tell us a little bit about your company and your history in HDD?
Yeah, so Geoengineers is about a 400-person firm. We're employee-owned, so I think we have about 300 shareholders within the company, and primarily geotechnical environmental consulting firm. And in late 2004, we bought a small company that specialized in HDD design and consulting, and I got involved with that group back in 2005, basically right after we bought them, and found it very interesting. So I personally have been doing that since 2005, just headlong into HDD design, consulting, construction, basically observation, things like that, field engineering. And personally, I have a background in geology. I have a bachelor's in geology, and then I have a master's degree in geotechnical engineering, so soils and rocks. And you know, the way we look at it is to understand HDD as a process, a construction process. We have, you know, a lot of experience with that and with our field experience, and then we also have the knowledge of the subsurface, right? We understand how the subsurface and the drilling kind of interact, you know, so when we look at a design, we can look at it holistically, I guess, if you want to use that, And so, yeah, that's kind of my story. Been doing it ever since, and then we hired, Gary came on about 4 years ago.
5 years, just over 5 years ago. Yeah, so I have a little bit different trajectory. I started out in the pipeline industry as a laborer, worked my way up through, you know, became a driller, then a superintendent, and then I went back to college after that. So I've been with Geoengineers about 5 years, but in the pipeline industry, you know, 22, 23 years. I also have a master's degree in geologic engineering, as Mark said. You know, really enjoy, you know, working with the subsurface and seeing how things interact, and, you know, in the rotary drilling world.
Well, thanks, guys. We're thrilled to have you with us in the studio. All right, getting right into our discussion. I want to start with maxi rig utilization, which has historically been driven by mainline oil and gas infrastructure. So my question is, from a design perspective, how is that changing?
Well, I'd say from a design, things are getting more complex. You know, there's a lot. The idea of open cutting a lot of locations to install new utilities is, you know, people don't want to see it. People don't want the disturbance. There's, let's say, environmentally sensitive areas. I mean, we've seen drills under wildlife habitat areas. You know, Louisiana black bear, they didn't want to cut a pipeline right away, so we drilled under a big wooded area just to prevent that. So, you know, things are getting more complex because we're trying to squeeze some of these projects into tighter and tighter locations with a lot more utility conflicts, a lot of other structural conflicts we're trying to avoid. And then there's, the regulatory aspects, in the past, frac outs, invert returns used to be a thing. Nobody really cared. You go clean it up. But, from the regulatory agencies now made that a much bigger deal. So there's a lot bigger spotlight on the industry when it comes to those sorts of things. So it's really put the contractors and the designers under a lot more pressure to look at the risks ahead of time, at least from the designer standpoint, and then for the contractors to be a bit more diligent during construction, to not just be, we're probably going to frack out and we'll deal with it. It's like some of these projects, if you frack out in a bad location, you could have your permit pulled. So, Gary's seen some of that as well.
Oh yeah, yeah, and the other thing Mark kind of touched on, we're losing a lot of real estate. There's a lot of the regulators want pipelines co-located with either overhead power lines, underground power lines, or other pipelines or something. So we're running out of real estate where traditionally you may have been able to go in and do surface open excavation and install the pipeline. But now we're seeing issues with that, where when we have to co-locate, there's just not enough real estate to do something like that. So you're needing to go more underground, longer distances, bigger packages, bigger pipe, and then, as Mark said, the regulator scrutiny. There's a lot of newfound, threatened species or endangered species or something that are kind of driving some of the permitting aspect. And the regulators really like the underground avenue. It's out of sight, out of mind, and most landowners would prefer that as well. It's not encumbering their property with any surface features, or it doesn't affect farming as much or anything like that. So. Well, there's a number of things that are really kind of driving that, that trenchless bus to make it more and more, preferred, in terms of, the installation technology.
And are you seeing a bit of the same, or what are you seeing out there?
Yeah, no, absolutely. I definitely agree with everything Mark and Gary just said. And from an OEM perspective, I think what that looks like is, to their point about just the amount of right-of-way is just continually shrinking. So we're seeing a desire for increased hole-making capability and overall capacity in a smaller footprint, right? And also, with a lot of these projects being on the East Coast and the West Coast, a lot of that water work down in Florida, still needing to be a very mobile machine, right? And so to that point, as Gary and Mark alluded to, the permitting process has become so cumbersome and become so drawn out, yet the expectation for completion has not increased accordingly, and in many cases it seems like it has decreased. So the ability to get that project done even faster is something that we're hearing directly from our customers. And so again, we're thinking about things like increased hole making capability, increased capacity overall, running 2 rigs in tandem to really add efficiency into that reaming process and just support a faster installation process overall. So definitely seeing those regulatory factors, hit home for us as an OEM as well.
Mark and Gary, this is a question for you. How are the incentives for decarbonization impacting project execution?
Yeah, that's a good question. So in one of the more recent spending bills, the federal government increased the tax credit for carbon, CO2, capturing and sequestering it from like $50 a metric ton to $85. So now the CO2 pipeline projects now are financially viable. And so they've started to design and actually in some cases start permitting on some of these projects. And I know of one that is just starting on the land acquisition for right-of-way. And so, that's why we're seeing there's 2 pipeline, I wouldn't say competing, but 2 different CO2 pipeline projects now that are, pretty far along in the process with the design aspects and whatnot. And, these will be capturing CO2 from ethanol plants here in the Midwest. And one of the interesting aspects is that these ethanol plants, the emissions from them are like 95% CO2, and the emissions don't require a lot of processing. So if you're capturing those emissions, it's a pretty efficient process to process the gas and then get it in a pipeline, and as opposed to maybe some other sort of industrial plant where maybe their emissions is 45% CO2. So from these ethanol plants, it's a lot more financially viable because it's so much more concentrated in those emissions. So, one of these CO2 pipeline projects will include a Mississippi River crossing, about 8,000 feet, almost entirely in limestone bedrock. Basically, it's kind of a demonstration of, it's not an oil and gas pipeline, but there's, markets for these maxi rigs because sometimes large rivers need to get crossed, and at the end of the day, it doesn't matter what's in the pipe. We need a pipe in the ground. So
where Mark left off there, I could talk a little bit about some electrical projects that I'm involved with. And there are actually, numerous more than what I'm involved with all up and down the East and West Coast. A lot of the aging electrical infrastructures, it's very prone to damage, just due to its age and, all the maintenance that's required. So we're seeing a lot of actual, overhead utilities being replaced, for either for redundancy or just to, instead of repairing them, they're just taking the overhead portion down and putting them in the ground. And it's better for the long-term environment. The safety part is you're not as affected by weather events, hurricanes or tornadoes or whatever. And the long-term benefits are great. People aren't having to look at these things forever.
Yeah.
So a lot of folks are really liking that aspect, and that kind of leads also into the offshore wind. We're seeing a lot of offshore wind development or projects, being proposed, especially up and down the eastern seaboard, all the way from New York all the way down into South Carolina or Florida. I've heard of some down in Florida. And even on the West Coast as well. I think there's one out in Oregon where they're proposing to do some stuff. And, basically for that aspect, there's still rivers to be crossed, there's still highways to be crossed, obstructions of some sort. And the other part there is now you have a shore approach where you actually have to put the cable, you have to bring the cable on shore. So the best way to do that, with the regulatory piece that we talked about earlier, open cutting that beach head, that beach approach is pretty much a bygone event. Several 20, 30 years ago, it was pretty easy to be able to dredge it ashore and install it that way. But that's not really something that folks are wanting to look at anymore from the regulatory perspective. You have too many, potentially species that would be affected by large construction disturbances on the beach. So a lot of, that's driving a lot of, also maxi rig type stuff where, you're installing 42 or 48 inch, HDPE conduit for several thousand feet from shore and onto the ocean floor.
And how about you, Andy? Is there any projects outside of oil and gas that Vermeer has been involved in?
Definitely. And before we kind of get into that space, I just kind of wanted to reiterate that at the end of the day, we have these critical resources, whether it's within the energy matrix or it's, on the water side of things, and we need a method to get it from A to B that's going to be least invasive and, kind of bring that highest level of stewardship to the environment. And it's really important that there's folks out there like Gary and Mark that are kind of bringing that additional expertise to the field, coming alongside the contractor or the owner, and doing that really important analysis from a hydrofrac perspective or a pipe stress analysis. That's really even taking the level of expertise and stewardship of the industry even to kind of another level to make sure that we're really, kind of being a more sustainable process and really just bringing that higher level of expertise to society as a whole, really. So I just appreciate the work that these guys have done here today and continue to do.
And I'd say, we enjoy working with contractors. I don't know, sometimes there's maybe a little bit of a contentious relationship between the engineers and the contractors, but, I actually enjoy it because, I think sometimes, maybe contractors, they may not have, a lot of them don't have the resources to do in-house engineering.
Right.
And so, some of these projects, they'll be awarded a bid, but they're like 60% design.
Right.
So then they're required by the owner to do some calculations, do a hydraulic fracture analysis.
Right.
So, we'll do that for them. It works good for our staff engineers because they get some experience starting to do this stuff. And I don't know, Gary, you probably have done more work for contractors on that.
Oh yeah, I really enjoy working for contractors too. A lot of times the owners will come to you and, they're at a really good place, but maybe they don't, like Mark said, they take it to 60% and then they kind of, rely on the contractor to go ahead and finalize it. So when we can help a contractor, maybe, take it the rest of the way, we can point out some risks that maybe weren't really well developed, during the planning phase. And it brings a better product for both the owner and the contractor at the end of the day. And at the end of the day, we want the installation to be as successful as it can be. We want it to be easy, minimizes the risk to the extent practical and possible. And then, it leaves everybody involved with the project, a really good feeling about how things were done. I've been involved with projects that did not go that well. And at the end of the day, sometimes you're just like, man, I'm just glad that project's over. And it doesn't need to be like that.
Yeah.
And I think one of the things that we can help contractors do is to kind of advocate for them, because, there's certain aspects of HDD that are, maybe more technical, where they don't have a background, like pipe stresses or the hydraulic fracture analysis. And we can help articulate, work with the contractor, articulate to the owner why these things are risks and maybe some of the ways that they can mitigate them. It gives the contractor a little bit more, credence with the owner, so that, at the end of the day, like Gary is saying, we could get a more successful project, and everybody wins.
Yeah, absolutely. That's adding a lot of value to be able to come alongside the contractor and kind of advocate for that more technical component of the installation process that sometimes they just don't have their arms completely around. And it's some great work that you guys are doing. But Maggie, back to your question about projects that we've been involved with. So we've been fortunate enough to be involved with, several, I guess a couple that I would mention. We had a D750 and D220 by 300 involved with actually the PacWave energy project up in the kind of the Northwest, where they were using HDD method to bring power from the tidal currents out into the ocean, onto the grid onshore. We had a 330 and an R9 on an offshore wind project out in the Northeast, to Gary's point. See a lot more of that on the horizon. Also, we had a D100 and an R250C down in Florida doing some kind of 1,500-foot shots, 12-inch conduit for transmission lines, on the electrical hardening side of things. And then also just that whole Florida kind of southeast region, there's been a lot more water, municipal type of projects going on down there for wastewater as well. So, and that's been some smaller stuff, but also, some big stuff, 36-inch or 42-inch. So there's definitely been a kind of a plethora of new applications that Vermeer has been involved in. And, to the point like these gentlemen made earlier, I think there's going to be a lot more of that with, carbon capture and also the build out of the grid. So we look forward to more of that on the horizon.
Yeah, very cool.
Yeah, and I would say that, a lot of this funding, these funding packages over last year have provided funding not only for like some of these CO2 projects and other research into like decarbonization, things like that, but a lot of it's just been put in, a lot of money too has been put into just water infrastructure, water, wastewater too. Right. So, a lot of money should be becoming available. One thing I would say is that there's kind of a delay, from the time the money is available, it takes longer and longer now to design and permit these projects. Right. So even though the money may be released out there for these things, it's going to be a little while before contractors start seeing RFPs for some of this work. So
that's good to know too. I think sometimes it's, we see these massive figures be released,
billions of dollars,
right? And then we wonder how is that really moving the needle. So it's good to know that it's good for us to understand that it just does take time, but it does move the needle for sure.
Mark, what are some of the key differences or nuances of the new energy sectors that we discussed here today that viewers should be aware of?
Well, I'll talk about both CO2 pipelines and hydrogen pipelines, let's say, because those are kind of a newer thing. I mean, as of right now, there are hydrogen pipelines in the country, there are CO2 pipelines in the country, but with some of this funding and some of the research being done and the direction things are going, there's a potential we could see a lot more CO2 pipelines for sure, maybe not as many hydrogen, but I would say from a contractor's perspective, from a construction standpoint, there's really no difference, when it comes to an HDD. It's a steel pipe, I don't know. I guess you could say the materials may be slightly different, but at the end of the day, it's steel pipe. So I don't think it's going to be a big thing for them. I think on the electrical side, Gary's got more experience there, and he can speak to some of that.
Yes, on the electrical side, it's also just a pipe. From the beginning, you still do the same stress calcs, you still do the same hydraulic fracture analysis. Design components are very, very similar. Construction, all the way up to pulling the pipe in the large diameter casing, pulling that into the ground, it's pretty consistent with what you would do for oil or natural gas or anything like that. I guess probably the primary difference is at the end of the day, you need typically it's an HDPE pipe and not a steel pipe. And then there's a step that you go further. Once you get the large diameter casing in, Then you typically pull in smaller interduct packages where they house like the ground cables, the conductors, oftentimes fiber optic cables or things like that. And then, the final step that we typically see is like a thermal grouting process. So the thermal grouting process involves basically taking the water that was put in the HDPE during the installation and replacing that with like a grout that's designed to dissipate heat from the conductors and the ground cables during their operational lifespan. And that kind of just helps, it helps with reliability, helps them last longer. And, it's one of the, I guess the final step that we typically see. So that's not something you would typically see with oil or gas, or water, installation.
Well, those duct bank bundles, they're not maybe, let's say, a normal bundle, because of the extra instrumentation and stuff that.
Yeah, during the thermal grouting process, there's oftentimes extra instrumentation that you would put in to help, evaluate how well the grouting operation is going. You really, the thermal grout it's very important that you get the maximum amount of thermal grout in the installation that's possible. Otherwise, you don't dissipate the heat, the way that it's designed. And that heat dissipation, as I mentioned earlier, if you're not able to dissipate that heat properly, it will affect, the throughput, how much electrical current is delivered, how how that in turn affects how useful that is to the end user. At the end of the day, if it doesn't provide all the power they need, then it's not really, there's no value in doing it.
Yeah. Now, does the HDD contractor pull that bundle in?
Typically what we see is the HDD contractor will pull the bundle in, and then they would hire a specialty subcontractor to do the grouting. They would still be responsible and support that effort, but it's not something that's very, that's commonly done by HDD contractors. So it's kind of it's a different process than what most HDD.
Yeah, I can imagine with all the sensors and stuff.
Yeah.
Be careful not to mess any of that up while you're installing.
Yeah, and it's very important that the sensors, in my experience at least, that are used, because otherwise you may leave more water in there, and the water can degrade the thermal grout and reduce the effectiveness of the grout itself. So it's definitely a very unique portion of that installation that we don't see in other market sectors.
I think just to add to that too, there's a couple things that are really sort of coming to the forefront, and that's one of them is just being more sustainable, right? So as an industry, how do we make this process even better? And there's a method out there that's kind of been accepted as if you've got a really long crossing, let's just say, for example, 7,000-8,000 feet. A lot of times we're seeing that being designed as an intersect, right? Because the steering technology has gotten so good, so precise, that they're able to just make that intersect process so efficient. And another piece to that is that the owners, the contractors are realizing that the annular pressure of two shorter bores is significantly less than it is on one longer bore, right? So that's a consideration. That's something that's being done to be just kind of increase that level of stewardship for the the waterways that are surrounding these projects, right? So as we look at that, so we've got a second rig there now completing that intersect process, and like Mark and Gary alluded to earlier, the permitting process can be so drawn out, but again, the expectation for completion installation has not been extended. So we're seeing contractors leaving that second rig on site, running those two rigs together in tandem just to help add efficiency into that reaming process, so they can address that reamer from either side, so that way they're not being forced into push reaming. They can pull ream from either side. That allows them to be much more efficient with their mud management because they can pump fluid from either side. As long as they have, of course, a mud pump and a reclaimer on both sides. So really adding a lot of efficiency into the application, into the installation process, but not just for the sake of efficiency. There is really just that desire and that focus on being less invasive to the environment around us. And I think as we look at these new drivers, whether it's critical resources like water or just the energy matrix, there's that increased focus on being more sustainable and less invasive.
We started seeing, like you said, intersects on really long drills. And, there is an instance or a case where you almost have to do the intersect, and you almost have to be able to ream the hole from either side, just from a technical standpoint. And that's for levee crossings, like Mississippi River crossings, where you have a levee on both sides.
Great point.
Because the Corps of Engineers has very strict design requirements and then also construction requirements where they limit your annular pressures during pilot hole and reaming.
Right.
So you have to run a pressure tool during the ream pass, and you can't exceed a particular limit. So on these long crossings, if you're pole reaming back towards the rig and you start getting high annular pressures,
Right.
you can just trip the tool out, ream it from the other side,
Right.
And so, you can really reduce some of the risks of high pressures, invert returns, because typically I think most times you'd see a rig on both sides during reaming was like a long rock job or something, right?
Yeah, traditionally that's where you've seen them most. What I'd add too, in certain ground conditions, subsurface conditions, being able to do a bidirectional pass, pull the reamer from both directions, can really reduce risks as well. And whether that's with getting the pipe stuck or just damage to the coating, if it's a natural gas product pipe or something, or natural gas product carrier pipe. So there's a lot of benefits. And when I first I've been in the industry for quite a while. The intersect method didn't really catch, until probably 2007 or 8, something like that. And from there, it's like you mentioned, the steering systems and guidance systems are very, very precise. And now we even see not only crossings that you just couldn't do, with a single rig, 13, 14, 15,000 feet crossings are being done now. And you just would not have the capacity. The drill pipe, wouldn't be able to withstand, to drill a pilot hole that far. But we also see some smaller crossings that you could probably do with a single, rig. We see those done with intersects just because it can, be considerably faster. Sure. It maybe doesn't cut your time in half, but it definitely cuts a good chunk out of it.
Right.
But with with the intersects and two rigs, it's not the end all at all. You still increase risks. Typically, you see drill pipe that just gets degraded over time. A lot of reverse bending cycles, a lot of fatigue, and just metal loss. So the drill pipe doesn't last forever.
Right.
It's a consumable item, unfortunately.
Right.
Not everyone wants to admit that.
Pipe.
Yeah, unless you sell drill pipe. Not everyone wants to admit that, but it is definitely a consumable.
Right. Yeah, an expensive one at that, but
indeed,
it is a consumable. So.
This has been a great conversation today in the studio, and thank you to Gary and Mark for joining us here in the Vermeer Mile to talk about where the industry is headed in HDD. Vermeer is always here to assist our customers and partners and has an impressive network of over 600 industrial and forge dealers around the world, ensuring our customers receive a consistent, personalized experience, all leading back to providing them the parts and equipment to keep their yellow iron working productively. We'd like to thank you for joining us today on this edition of Let's Talk Shop. If you have any questions on horizontal directional drilling or anything else you learned about today, please visit Vermeer.com or reach out to your local dealer.